Good morning. I would like to thank everyone for being here. I know it's a fresh day, early start. Thanks for taking your time and being over here. So before we start, I just wanted to ask a simple question. How many of you have Netflix subscription? Quite a few, correct? So imagine you are watching a blockbuster movie. You are in between an action sequence, and suddenly it buffers. What would you do?
Change the vendor.
But immediately, what would you do? Sorry? Wi-Fi? Yeah? The first thing that we blame or we check is our Wi-Fi network or the broadband network, correct? So what are we actually looking at? We are looking at the network, which is connecting this, correct? So nowadays, with every business that is digitalizing, correct, networks have become very critical. It's not a good to have or an optional thing. Every network out there.
I can hear you all the way to the back.
It's not audible?
It's not audible. At least I can hear it from here.
Am I audible? The back seats? Am I audible?
She's.
No? Is it on?
No.
Hello? Okay. So, am I audible now? Okay. Thank you. So, once we have our networks, which are very critical for any of our businesses, we should also be having the network security, because our businesses runs on these networks, and these networks, if they go down, our businesses are impacted, correct? So network security matters. And the whole concept that we want to bring to you today is, while you're designing your network, security should be an integral part of your network design. It cannot be an afterthought. So the networks and security should go hand in hand, and it should start from the designing phase itself. Okay. So let me quickly introduce myself. I'm Sunil. I'm Senior Product Manager of Catalyst Switching Business Unit, and I take care of the software enablement. So I'm mostly focused around security solutions integrations. So with switching Cisco over Cisco solutions, especially the networking and security integrations. And I also take care of Silicon One software enablement. So I've been with Cisco since 2007, and I was in various roles, starting from development, technical marketing, to competitive analyst, to product management. So I have a vast experience in different roles, jack of all trades. And
Hi. So my name is Ama. I am from Accra, Ghana, and I got my bachelor's in electrical engineering from Michigan State University. I've been with Cisco for almost 4 years now, and I've been also in the enterprise switching BU as a technical marketing engineer. So my focus areas are the Catalyst 9200 switch, the switches security technologies that we're going to be talking about today, and also Catalyst 9000 virtual. My hobbies include traveling, photography, and also reading. You can continue.
Thanks. Thanks, Amma. Is it audible now? Especially the backseaters? Okay, thank you. So, what are we going to learn today? So, first I will start with why network security matters and what network security means. And then we will see how Catalyst 9K switches are designed to provide or to build secure networks. And starting from day 0 to day n. When I say day 0, it is like when you're purchasing the box, adding it to your network, till you are RMAing it, correct? Or you're end-of-lifing it. So across the life cycle, what are the security features that Catalyst is providing, and how our Catalyst 9K has been designed to build secure networks. And I want you to walk away with a plan to enhance your network security. So this session, I'm not going deep dive into any of the technologies or bits and pieces. We'll be talking about a lot of features, lot of things. And these are just the main features. There are again sub-features and multiple features. I'll not be covering every and other feature. But the main point that I want for you to understand is what all the capabilities which are already available on the Catalyst 9K switches that you could leverage to enhance your network security. Obviously, some of those you have already been using it, and the others, if you are not familiar with, we will introduce you that, and then we can see. In the meanwhile, I want you to come up with a plan. Okay, this is there, this is not there. What is the next steps, correct? And you can have a discussion with us. So there is an app in a WebEx. You could have any queries. Both of our speakers are there, and even we have added few subject matter experts. So any queries that you have across this session on Catalyst 9K, you could connect with us. So in a hybrid world, when I say hybrid world, you could have anyone connecting from anywhere to an application, correct? And the application can be hosted anywhere. It's just not at one place. You could now see the applications in the cloud, in the data center, or on-prem, correct? So the expectation is very simple. Wherever I'm connecting it from, I need to have access to this application, wherever it is hosted, correct? Very simple expectation, but there is a lot of complexity behind this because it passes through multiple networks, correct? You would know wireless, switching, then WAN. So there are multiple networks, and there is a lot of complexity which is behind this. Usually, you see the network is the one which actually connects these hybrid users with the hybrid applications, correct? And what we have traditionally saw, all our security investments go to the endpoint, or they go towards the securing the application, end application. So most of our security investments are either on this side and that side. But there are threats everywhere. The network cannot be discounted. So protecting your endpoints and applications has always been the focus, but the network unfortunately gets ignored. So today, I'll be focusing more around the campus and branch scenarios, and we'll be seeing where our Catalyst 9000 switches can be used for a secure campus and a branch infrastructure, and our Catalyst Center can be used to manage these, correct? The network is many pieces, but today my focus is more around the Catalyst 9K, which is more around the branch and the campus. So defining security, correct? So how secure is your network? So you have your network devices. These are your building blocks, correct? And the software which is running on that and the hardware defines your network, and these are the building blocks. You build your network using that. Are you sure all the network equipment out there are not counterfeit? Sometimes the counterfeit may be just a component, an uplink module, a power supply, or a USB out there, which would give a backdoor entry if it is a counterfeit. The image that you're running can also be tampered, and if it is tampered, it gives you a backdoor entry into your network. So the network infrastructure needs to be secure. Once you have built your network, you need to know exactly who is getting into your network, who is connecting to your network, and with what device they are connecting, and what access they have. So how many of you know exactly what is connecting to your network? Any hands up? Confident? You know all the devices that are connecting? Unfortunately, this is the truth. We don't even know what all devices are connected to a network. So unless you know what is connected, how would you protect it? So you need to be aware of what is connecting to the network to protect the network from. And once your access is controlled, you have a onboarding, you have done it, you know who is connected, the traffic flows through your network. Now, somebody can tap in between, can peek, man-in-the-middle attacks, or somebody can sneak peek. So are you sure the transport, what your end-to-end communication, is it encrypted so that even if somebody goes and sneak peeks into it, they don't see any traffic, it's encrypted. And sometimes what happens is your legitimate users, your credentials may have been compromised. The user is legitimate, but the credentials may have been compromised, or the laptop or the device that they are accessing may be infected. Then there can be threats during the later stages. So he may look like a legitimate user, but do you have a visibility, like what is this user doing? Is there any anomaly in his behavior? Can you monitor that today? That is required, correct, to secure your network. It's just not, I gave access, I know this is a trusted user, but you need to constantly check on that trust. That's what we call end-to-end visibility, which would help you detect any threats out there. And your traffic or your communication is just not within the network, it's across the WAN. So you'll be connecting to your branches, you'll be connecting to few data centers or somewhere. So any traffic that is flowing across the WAN, that needs to be secured. Similarly, now with the remote hybrid world, correct, remote users connect, and those connections also need to be secured. So when I say security, these all are the components that you need to evaluate. Okay? Now you can think in your mind, like what all pieces I have already there and what I need to get into your network to make it secure. Once all of this is done, the criteria that we want is you want to have one common security policy, correct? And that security policy across your network, it should have the same access. Irrespective of whether I connect from my home, I connect from the branch, I connect from the headquarters, I would still need to get the same access. So that is how you define your unified policy or a common security policy. So this is what a secure network means. So coming to our Catalyst 9K portfolio, we have our Catalyst 9K starting from our compact, access, distribution to core. If you see, we have all the variations. We have different SKUs to address different use cases, modular and fixed. The beauty with this Catalyst portfolio is all of them run on a single UADP ASIC, and they use the same iOS XE operating system. This iOS XE is a very flexible and a secure operating system. And you all would know, we have a single image starting from 9300 to 9600. So that is the simplicity that we are bringing in. And anything that we are securing at one place, obviously that is applicable to all the places. And if you see, we have also added our X series on the top. So X series will not replace the normal Catalyst. It is specifically designed to address use cases which the existing platforms were not able to address. So those were targeted for specific use cases. And we have also introduced our Silicon one in our core platforms. And the beauty is those, even though it runs a different ASIC, it uses the same operating system, and also it uses the same image. So we abstract all that complexity for you. So we simplify that. So coming to the security features, correct? Like we have talked what security means. So today what we will be focusing is Catalyst 9K lifecycle. When I say lifecycle, from the day I get the switch, plug in into my network, get my day one, I configure everything, I ensure everybody is accessing correctly, all the rules are defined, I ensure that day two, later on, if there are any threats or anything which are coming in, till day end, which is like the end of the product. So we do this across day 0 to day end. So I'll hand it over to Ama, and she will take it from you.
Thank you so much, Sunil. That was a great introduction. Thank you so much for helping us understand why network security truly matters. So like Sunil mentioned, we're going to go through the life cycle of a switch. And in each stage of the life cycle, we're going to try and understand what are the securities mechanism, what are the features, what are the technologies that the Cat9K come equipped with that's going to help you secure your network. So with the life cycle, we're going to start with day 0, right? Securing the infrastructure. So the infrastructure is the network device, the switches, the routers, the firewalls that you have in your network. In this session, we're going to focus on the Catalyst 9000 switches. How do we ensure that if there's an attack to your network device, how are you going to prevent that if you have your Cat9K? If there's an attack, your network is pretty much all compromised, because the logic is that if an attacker gains control of your switch, all the traffic passing through, they own it. They can do whatever they want with that data, right? They can exfiltrate it. They can set up command and control channels. And so how are we going to protect our switches? On the Cat9K switches, we have something we call the trustworthy technologies. So let's look at the different attack scenarios and how the trustworthy technologies is going to protect you. For the first one, let's take an instance where there's a counterfeit device. As Sunil mentioned, you can have there could be an installation of a counterfeit switch in your network, and this can be a cause of launching of other attacks. The good thing is that with your Catalyst 9000 switch, when you buy a switch, it comes from manufacturing, it comes embedded with a TAM chip. Now, what is this TAM chip? This TAM chip is a tamper-resistant chip that contains something we call the SUDI certificate. And this SUDI certificate pretty much contains the serial number of the switch, the PIN of the switch, and so these two values are going to give your device or your switch a unique identity. And so now, anytime there's going to be some sort of onboarding or feature that requires your switch to prove itself, this SUDI certificate can be used to ensure that you're not running a counterfeit switch in your network. Another attack could be the installation of malicious software in your network. That's also another example that Sunil mentioned. So at Cisco, all the images that we provide to you all come signed and go through a hashing algorithm, right? So before any image is allowed to boot on your switch, it goes through verification processes, and the hash values are always checked. So you can be rest assured that before any image is even allowed to boot on your switch, it's already valid, right? It's any sort of image that is malicious or has been gone through some sort of modification is not going to be allowed to boot on your switch. Another sort of attack to your network infrastructure could be modifications to your BIOS, right? Once your BIOS is corrupted, any sort of malicious image can be allowed to run on your switch. So how do we protect that if you're using a Cat9K switch? So we have a process that we call secure boot that I'm going to detail on the next slide. This secure boot pretty much ensures that before you run any image on your switch, your BIOS is protected. And finally, when your switch is in production and there could be some attacks, right? There could be some injection of malicious code into your switch. How do you protect? When you use your Cat9K, how are you protected, right? So we have something we call runtime defenses, and this provides you with multiple different features or technologies that protect your switch from any sort of attack during production, right? There could be, through vulnerabilities, there could be an attempt to try to inject certain code into memory. And so an example of a runtime defense is the address space layout randomization. And what this does is it randomizes the memory of your switch. And so attackers do not have a fixed layout of what your memory looks like. And so they don't know exactly where to insert or inject certain code. And so that's one way we protect you from those sort of injection attacks. Okay, so I did mention the secure boot process, which is going to protect your BIOS. Let's just go through these steps and understand what exactly it's doing. So in the first step, we have the TAM chip I mentioned about. So this TAM chip comes embedded in your switch at manufacturing. And this TAM chip also contains something we call the microloader, right? Before your CPU boots, it requires some sort of instructions. And these instructions are stored in the TAM chip. And so these are not going to be modified when you get your switch. And so now your CPU boots with these instructions, and once your CPU boots, it's now going to verify the BIOS, right? The BIOS comes pre-signed. And so now the CPU is going to ensure that there has been no modifications to your BIOS. And so that's where the protection comes in. The CPU is going to now verify and make sure that the BIOS has not been corrupted. And once this is checked, now the BIOS has permission to install images on your switch. Like I mentioned, all the images that we provide at Cisco all come pre-signed. And so the BIOS is now going to go through and check, validate the image that you want to run on your switch. And this is going to check the hash values that the switch provides and cross-check it with the hash values that Cisco also provides in their key value pair. And this is going to make sure that before the image you want to run is valid and has not been modified. Once the image has been checked and everything is good, now we can be rest assured that the image that's going to boot on our switch is valid. Now that's the software verification. How do we know that the hardware we are running is not even counterfeit? So this is going to now move into from your CPU or from your software. Your software is now going to query the TAM chip, right? So we moved away from verifying the operating system, and now the operating system is now going to verify and make sure that the hardware is correct. So it queries the TAM chip and says, where's your 2D certificate? I want to get these values. It queries it, it reads it, and once it validates those values, it now says that, okay, this hardware is legit, and so it's going to allow it to run. And so this process, you can see, we're now validating the software, and the software in turn validating the hardware. And each step, anytime there's a failure in each step, the switch does not boot, right? So it's a sort of it's a form of steps where every step is validated before the next step is allowed to boot. So this is about the secure boot, and this is one way in which we protect your switch from any sort of counterfeit image or device or hardware. Okay. Now we're moving into secure provisioning, right? You've been able to secure your hardware. You know that the hardwares that you have are all legit. Now we have so many devices in our network, and we want to be able to onboard them and provision them at scale, right? And so we use something called the day zero technologies. Now, we have to take into account that whilst these day zero technologies provide us with that automation that we need to be very careful because there's a possibility that we can onboard malicious devices into our network. So this stage of the life cycle, we really need to take security into account. These are the 3 day zero options that Cisco that the Cat9K switch supports. Let's look at each of them and see how and look at the options provided and how in each of them, what are the security mechanisms that do ensure that you're securely onboarding your switch. The first one is the pre-boot execution environment. So this has traditionally not been a secure mechanism, right? One, it relies on TFTP and HTTP, and these protocols are not encrypted. The second is zero-touch provisioning, right? Now we know that with zero-touch provisioning, you get your Python file from your server, and then you're able to provision your switch with those configurations in the file. Now, this has traditionally not been safe, but now we do support something we call the secure zero-touch provisioning. Now, what this does is that now, instead of just allowing the switch now retrieving any image from any server, or there's no validation, with the secure zero-touch provisioning, there is a 3-step validation process, right? Now, before the switch even retrieves the image from the ZTP server, it validates to make sure that that is the right server it's supposed to be receiving the image from. The server also validates the switch to make sure that that is the right switch I'm sending the image to. And the switch also validates the file before it allows it to even provision, before it even allows it to run, right, on the switch. So with this 3-step validation process, you can rest assured that if you're onboarding your switch with this secure ZTP, you're going to always, your switches are, the devices that are onboarded onto your network are always going to be valid. The next option is the Cisco Network Plug and Play. Now, this has always been a secure process. One, because it always uses the SUDI authentication, where before the switch is allowed to onboard, it has to verify itself with the SUDI certificate. It also uses HTTPS, which is a secure encryption communication protocol. So these are the 3-day zero provisioning options that we have, and we can see that obviously with secure zero-touch provision and the secure network plug-and-play, using these will be able to secure a network when you're onboarding your switches. Okay, now we've been able to secure our hardware. We've been able to securely onboard them. We're going to start connecting our endpoints, and this brings us into the layer 2 domain. Within the layer 2 domain, there's been a lot of changes, right? Moving from IPv4 to IPv6, there's been a lot of re-engineering that has been done, even within the security protocols, right? IPv4 has always had some sort of security features that have been supported, and so the same has to be done for also IPv6. On the Cat9K, we do have a framework or architecture that allows you to be able to secure a network in the layer 2 domain. I'll briefly explain the architecture and also how we can use the architecture to protect our switches in the layer 2 domain. So how many of you know about SISF? No one? Okay. So this is a framework supported on our Cat9K switches. And this framework pretty much consists of 3 building blocks, right? We have the binding table, we have the device tracking, and we have the device tracking policy. This framework essentially, what this framework essentially does is that it tracks all endpoints that are connected to your endpoints. It tracks the location, the movement of the nodes, and also the presence on the network. So it essentially creates a map of all the endpoints connected to your switch. So let's start with the binding table. What this binding table does is it pretty much creates a table of all the endpoints, of all the endpoints on your switch, right? It's able to contain, the binding table contains the IP address, the MAC address, the VLAN, and how it's able to fill this table with this information is that it gleans or it snoops information from packet sources like, from traffic sources like DHCP, ARP, neighbor discovery. With these type of traffic sources, it's able to read information from these and fill up the binding table with all, with the IP address, the MAC address of the endpoints connected to your switch. This binding table is very necessary because a lot of the features that run on the switch, like TrustSec, .1x, even the first hop security features, utilize this binding table, right? Before the feature is even able to run. So you find that a lot of first hop security features will require you to enable device tracking so that it can track the endpoints before the feature is able to run accurately. And then we have the device tracking, right? Device tracking, like I said before, is going to track the presence of the endpoints on your switch. So I've explained pretty much what the framework is. Let's take an example of how we're using this binding table to secure our network in the layer 2 domain. I'm sure most of you are familiar with first hop security features. An example here is IP source guard, right? With IP source guard, we can be able to protect our switch in a way that if there is an attacker that has joined the network and is trying to gain unauthorized access to start attacks like DDoS, and is trying to use the IP address of a valid host on the switch, it's going to essentially block that traffic, right? Because like I said, we have a binding table that has the VLAN, the IP, the MAC, the interface, all these information. And so before the traffic is even allowed to pass through the switch, it's verified. The IP source guard verifies this traffic information with the binding table. And so that's one way in which we're using the binding table to be able to enable the IP source guard feature and protect our layer 2 domain. And there are multiple first hop security features that use this binding table, but this is just one use case to showcase this. Okay. Now we are moving into the secure network access, right? We are going to start having our endpoints try to connect in the network, access different network resources. How do we make sure that these endpoints are connecting the right way and accessing the right resources? let's get a brief background into how traditionally we've done network access control. So previously, we used to have almost everything on-prem, right? We used to host everything on-prem. But now, there's a shift in the networking landscape. We find that we are adopting more and more cloud-based, we are moving more and more of our data and workloads into the cloud. We're also adopting more IoT endpoints within the network. And we're also shifting to a hybrid work environment. So a lot of people are now accessing the network from different locations. So if previously you had to just secure your on-prem network, now you have a huge or large attack surface to now secure, right? You have entries from the cloud, hybrid workers all over in different locations. So the way we used to do network access control needs to change. Okay, so that's where we have zero trust strategy come in, right? With zero trust, now having to just secure, if you're relying on just securing, trusting all the endpoints within your network, with zero trust, it has shifted, right? The strategy aligns very well with how we have evolved in the networking landscape. It's built on 3 pillars that I'm going to go through and show you how the Cat9K is going to help you to adopt the zero trust strategy. Okay, so we're going to establish trust, right? I mentioned that we have more and more devices adopting IoT endpoints within the network. Before we can even secure the network, we truly need to understand what are these endpoints that are in my network. Like, if you don't know it, how are you able to secure the network? So this is going to help us to truly understand and gain knowledge of what is on our network. And then with that knowledge, we're going to be able to segment the network in a better way than what we've traditionally done. And finally, we're going to continuously verify them. Like Sunil mentioned, we cannot just verify once anymore. We need to continuously monitor so that if there is a legitimate user that has been hacked and attacked, their access is blocked right from the start. Okay, so let's start with AI endpoint analytics, right? The first pillar, trying to establish trust of our endpoints. How are we able to gain knowledge of all the endpoints within the network? With AI endpoint analytics, we're now able to use deep packet inspection that is powered by the NBAR on the Cat9K, right? There's Cat9K supports NBAR, and so with that, we're able to now do the deep packet inspection of all the sources within the traffic, and then now we're going to be able to classify our endpoints even better than what we used to do, right? So before, we used to use network probes and static parameters, but now we're going to be able to truly understand what the endpoints are on our network. So information like what's the type of the network, the manufacturer, the vendor, the operating system they are running. This gives you even more understanding. And now even devices that you were not able to manage or know what was connected in your network before, with this, you're going to be able to have a more, you're going to have better discovery of those endpoints in your network. So this is with AI endpoint analytics, and with this data can be shared with ICE, which is the policy engine with the zero trust, and then we are able to go to create the policies and enforce the policies on our switch. Okay, so now we are going to move, now we've been able to establish trust with AI endpoint analytics, we're going to be able to truly understand what are the endpoints connected to my switch. Gaining that knowledge, we're now going to move into trying to grant access to these users, and not just granting them the right access, right? Having a right segmentation policy in place to be able to apply these policies. Okay. So there are 2 ways we can segment the network with the zero trust, right? We have macro segmentation and we have micro segmentation. With macro segmentation, essentially you're trying to create virtual networks and be able to create a first layer of segmentation where if a network, you can divide your network into IoT devices, corporate, guests, right? And so with this, anybody within the corporate network cannot actually talk to people in another VN until communication permissions are allowed with like a firewall or a router. So that's one way you can segment. But what if you can even do a better way, right? Granularly segmenting based on the roles or the behavior of your endpoints. When you're able to do this, it makes your work so much easier, right? With micro-segmentation, what we are essentially going to be doing is that the endpoints are now going to be classified based on what they're truly doing in the network, not by what you think they are, but what they're truly doing in the network. So within the VN, in the corporate network, you can now have not just corporate, you can have HR, you can have engineering, you can have marketing. Because essentially, not all these people are not accessing the same resources, they're accessing different stuff. So when you're able to segment based on that, you can have better policies set in place for these groups. So let's take a deeper look into microsegmentation using TrustSec. So traditionally, we've used ACLs, VLANs, which are all IP-based. And so the problem with this is that, one, it's IP-based. So anytime there's a change in the IP, you have to go back in and manually make all these changes. And so you are very prone to errors. Two, with more and more applications being added into the network, it becomes a hassle to always have these additions to these rules and policies. Okay, so what if there's a better way to do that? Like I mentioned previously, we can segment our devices based on their behaviors or their roles, right? And so once we're able to do that, we get rid of the VLAN and the IPs that we're using, and now we have a more logical segmentation in place that focuses on the behavior of the endpoints. So with ICE, which is our central policy management platform, we're going to be able to create these behavior tags, or SGTs. And these tags are essentially going to be able to provide, with these SGTs, you're now going to be able to create policies, right, that are specific for these groups. So most businesses really just want to create policies that are restricting or allowing access between these groups of people and what they are doing. So marketing cannot talk to maybe engineering. That's just an example. And so when you have this logical segmentation in place, it makes sense. It's actually more human-friendly to create these policies because you truly know and understand what kind of what communication you want between the different groups. So that's how we're able to do that microsegmentation with TrustSec. Because now, anytime your endpoint changes the IP, you don't have to go back in to change your rules. All this segmentation and policies are done logically, right? So whatever policy you define is based on their behavior and their roles, and not on their IP address. Okay, before we can even create these policies, we really want to make sure that we are creating these policies accurately. It's an application on the Catalyst Center that allows you to be able to deploy these policies in confidence, right? And what it does is that it analyzes your traffic with NetFlow from the endpoints. It analyzes information from your endpoints about these different groups you've created, and is able to understand the different communication protocols, the ports that they're using to communicate. And once you're able to visualize and see how these different groups are communicating, you're now able to know how to create these policies. You're not just going based off what you think, but based off how the network is actually behaving. And then now you're able to create your policies and push them onto your device. So with group-based policy analytics, it creates an easier way for you to truly deploy your policies in confidence. Okay, so finally, in the final pillar, right, we've been able to establish trust, create our policies with better segmentation. We want to always continuously monitor our endpoints and to make sure that once you've granted them access, they are behaving exactly how the policy expects them to behave on the network. So how do we do that, right? We're able to use different parameters, right? And be able to, with these parameters, check how the endpoint is behaving and assign them trust scores, right? So once you assign them trust scores, based on the range of the trust scores that they fall into, now you're able to deny them access, quarantine them, or even continue permitting them. And so like an example being the security threats, vulnerability metrics that each endpoint has. And this is something that allows you to continuously monitor your endpoints and ensure that once you've been able to give access to an endpoint or user, they're doing exactly what they need to be doing on the network. And finally, with the zero trust, SDA allows you to be able to have that automation, right? Be able to easily have endpoint visibility, segment, visualize your SGT, and be able to do the policy analytics I mentioned, how you're able to now create your policies in confidence using the traffic patterns of the different groups. Okay, I'm going to pass it off to Sunil to move into the remaining life cycle stages and the security provided.
Thank you, Amma. So you have seen how to secure your infrastructure, how to ensure you're getting the correct people and to give them the correct policy and how the policy stays with them along the network. And you have also seen how you continuously monitor the trust, correct? So all these pieces are now being checked. So as I told you, just have a plan. Build a plan like what is already available in your network and what you could add to your network. So continuing the journey, the day 2, like your network is all set. You are given the access. Now you know all are legitimate guys, correct? So if you remember like the Tom Cruise movies, Mission Impossible, the guy goes, he taps into the network, the wires, and then he sees what is happening over there, and he feeds another print so that the monitor screen shows something else. What is it they're doing? They're actually tapping the network, and there's a man-in-middle attack, correct? So in a real-world scenario, somebody could be tapping into your network. Maybe they are monitoring what is happening in your network. Some important mails, some confidential information can be leaked, correct? And you would not even know about it. So what we need to do for that? We need to secure the transport. So whatever data is flowing through your network, all the transport needs to be secured. So we have different transport security encryptions. The first one is WAN MACsec, LAN MACsec, it is within the network, WAN MACsec, across the network, and IPsec. Okay? So I'll be going through that. So MACsec traditionally is a point-to-point encryption. Okay? So encrypt one side, decrypt it on the other side. So MACsec can be used to encrypt the traffic from the host to the switch or between the switches. So, but it's a point-to-point. It's a layer 2. That's why I call it link encryption. Okay? And this is done at line rate. When you are enabling MACsec, it is done at the hardware. The ASIC does it at line rate. So you would not lose anything. Usually, when you are encrypting, decrypting, you would feel like, is my performance going down? No, nothing happens. You could have up to 400 gigs MACsec encryption and no performance impact. So typical use case scenarios. Anybody in a conference room is connecting back to the switch. That data, that host to switch, is encrypted. Across your buildings, you're connecting, correct? So across these buildings, this fiber or something is going somewhere. So somebody can tap in between. So those across the buildings, you need to encrypt. And another typical use case is you would have multiple floors. Each vendor has a different floors. And if you're in a floor number 1 and 3, it is passing through the floor 2. So you need to ensure that the traffic that is flowing through these different floors is all encrypted. So that is like the switch to switch. So MACsec can be used anywhere. It's a point-to-point, and you could use it. So this is just more for your reference, like we support SAP, but now with the authentication method, we all standardized on MKA. And we support 256-byte MKA. Okay? So coming to WAN MACsec. So in the LAN, point-to-point, it's fine. But what about across my WAN? So this is like extending your MACsec across the WAN. So what we do over here is we use the clear tag technology, which enables us to use any of these layer 2 carrier Ethernet networks, like your leased line dark fibers. You could connect them, and you could get encryption, end-to-end encryption across your WAN layer 2 with this WAN MACsec. Okay? And this is again a layer 2 thing, and it uses a different EPOL type. So in a simple terms, what is the difference between the LAN MACsec and a WAN MACsec? LAN MACsec, point to point. And a WAN MACsec, it's a point to multi-point. How could we do that? As I told you, the clear text, or when I say clear tag, it is nothing but the VLAN tag that we have is actually encrypted in MACsec. But here in WAN MACsec, we don't encrypt that .1q VLAN tag. We actually use that VLAN tag to identify the carrier. So that's where it is possible for you to have that multiple. So with that VLAN tag, you should be able to identify corresponding to this. So in WAN MACsec, on an L3 interface, you could create sub-interfaces, and you could have them assigned to a different VLAN tag, and you could have this multi-point connectivity. So again, WAN MACsec, you could use it for data center connectivities, like across your data centers, you have your lease line or L2 connectivity. You could connect them, you could encrypt them. Across the buildings, you could do them, and it could be a headquarters to branch, as long as you have that layer 2 connectivity. But it's very hard to get layer 2 connectivity. It costs, correct? Now with more and more internet coming into picture, layer 3 is available. It's cheaper. And IPsec has been there quite a time. It is a standard layer 3 thing. So now what we have done is we have introduced IPsec in our Catalyst 9K. So with LAN MACsec and WAN MACsec, layer 2, this comes a layer 3 standard wise. So you could have, you could have your 9300X or 9400X in your branch, and it would connect to your headquarters or your cloud with this 100 gig. So you could have up to 128 tunnels. So we have around 348 SAs. And all the X series models, as I told you, X series we have introduced it for special use cases, correct? So this is one of the use cases. The IPsec capability is only available on 9300X or 9400X. And we are also introducing it in 9500X. So this is currently in a limited availability. So we will be, if you see some of these stars, these are not yet available over there. These are all limited availability. But the capacity, if you see, it would be far more. It would go up to 400 gig. So a typical use case, if you're connecting to your branch, or if you're connecting to your cloud. So with more and more applications hosted on the cloud, and with most of these SaaS, you need to connect it to the cloud. So you don't need a router and a switch. You could consolidate everything from the switch. You could directly talk to your headquarters or to your cloud. So this is something, and you are doing it at a line rate. And again, you are not compromising on the performance of your switch, because this is done at the ASIC level by the hardware. So very low latency, 100 gig speeds. So just to summarize all the different types of transports, if you see IPsec, it uses layer 3. WAN MACsec and WAN MACsec, they are layer 2. And you have all the encryptions, 128 and 256 AEs encryptions are allowed. It is IP agnostic, the WAN MACsec. So because it is a link layer, layer 2. And the speeds, with WAN MACsec, every port, whatever your switch capacity is, every port can connect to the same bandwidth across your WAN. But IPsec, you would have a limitation of 100 Gbps or 400 Gbps based on the platform. And WAN MACsec is currently supported on 9600X and 9500X platforms. This is simple, and even the overhead is also relatively less. So till now, what we have seen is these are all the capabilities which are natively available on the switch. But now Cisco had a lot of security features. As I told you, I've been integrating with security solutions with us, correct? So these are some of the things. Where the iOS XE, we natively integrated the agents, like DNS security. So you don't need a different agent to be hosted. It is inbuilt into the thing. So DNS provides us the first line of defense. And as per the statistics, what it has been like 90% of the malware attacks, they use DNS. Unfortunately, the DNS is the one which is not monitored the most, correct? So what we could do, we could enforce this DNS security at a network level. So irrespective, on your host side, whatever may be the DNS server that you're configuring, as long as it is passing through the switch will intercept all the DNS packets, and it would send it to the Umbrella. And any sites which are malicious, Umbrella is regularly updated with all the malicious sites and everything. If it is from any malicious site, it would block it, and it would clearly pinpoint who is the source, where is the source coming from. And it is integrated with Active Directory, so you could have different policies for different things. So Secure Network Analytics. So another thing that we have from our switch is flexible net flow, which gives you complete record, like what is going in your network. Because the network is the one all the traffic is flowing through, so all that information is available with us. So at a hardware, we could collect all these FNF records at line rate, and even if you have encrypted traffic, we have ETA. All the encrypted traffic analytics also can be sent to the collector, like Cisco Secure Network Analytics or any other collector or any third party, and they could give you an end-to-end visibility of what is happening. So Cisco Secure Network Analytics, it does the baselining of your behavior, and any anomalies in your network, it uses the AI/ML algorithms and decides and notifies any anomalies in your network. So for that, the switches power them with the FNF records. Now you are seeing the connectors. Beyond this, in your life cycle, all these switches will be there at least minimum 3 to 5 years or more, correct? Now there is something more you want, which is not natively available. So the beauty of this switch is you have an app hosting infrastructure. When I say app hosting infrastructure, it provides you the flexibility to host applications on the switch. So you don't need additional server or some of the agents which are there, you could actually run on these switch natively. Okay, so one of the typical example what you have seen is ThousandEyes, which would give you the monitoring, end-to-end monitoring across the internet. So those agents can run, and it could run those tests over here. And what we have recently introduced is a firewall on this. So you have a ASAc firewall application, which would give you stateful inspection on the switch. So there was a scenarios, especially with the IT/OT integrations being more and more, we are seeing that as per the compliance, they wanted stateful inspection across these traffic that is going across these domains. So switch is always a stateless. So we added a firewall, ASAc firewall, a light instance, and then we hosted on it, and we were able to get that stateful inspection. So this firewall would have all the capabilities of ASAc, and what you need to run this, you have a app hosting infrastructure, so you need a Catalyst Advantage license, DNA Advantage license, and then you need a SSD. So just by adding a SSD, you could virtualize the firewall and host it onto it. And obviously, you need a ASAc license, which is a 100 meg or 1 gig. And most of the scenarios, what I have seen is IT or IoT traffics. These are few kilobytes to embed. So this would do the trick, especially for the stateful inspection, for segmentation, and for policy enforcement. It can do SGT-based policy enforcement. And this can also provide you IPsec capabilities. Now, the traditional 9300s, which were not able to do IPsec, by hosting this, now you could add encryption, IPsec encryption onto the boxes. So typical use cases, as I told you, in a factory floors where the firewall was sitting next to a switch, it is virtualized, and it does the segmentation and the zone-based, any traffic that is more flowing through, you would have stateful inspection. And any IoT devices which could not have encryption capabilities, now the switch could add those encryption using the ASAc. And remote management, any accesses for that. So now you have seen the switch, now it has come to the end of the life. You need to refresh it or you need to RMA it. The major concern is what happens to all my confidential information. There are a lot of configurations, there are a lot of username passwords, there are certificates, there are a lot of things that are stored in your switch, correct? So we have got a secure data wipe. So this secure data wipe goes and sees all the data bearing components, and wipes them completely. Even what Act 2 chip, what Ama was mentioning, even anything that is personal information, any certificate which is on the Act 2, that is also cleared. Or even if a SSD or a USB which is already connected to it, it wipes out everything. What would this enable? This will give you the product take back. You can involve over there, and it would help you to reuse, repair, or remanufacture. So it is a sustainability effort also which is there. So the key takeaway, Catalyst switches are designed to secure your network. We have seen from secure infrastructure, secure access, to transport, to end-to-end visibility, correct? So all of them are provided. And I want you to go start your journey to enhance your network security. And we, Cisco, are there with this journey, because each of these topics, again, can have a 1 hour or 2 hour dedicated sessions. So plan what you want to go next, schedule those meetings, and we'll be happy to assist you to get to your next level of enhanced security.
Okay, thank you, Sunil. So as Sunil mentioned, we want you to take away a couple of things from this session. We want you to evaluate your network and truly understand what you're lacking from this session we had. What are you doing? What are you not doing? What do you think you can do better? And when you've been able to do this, what are some of the features that, what we mentioned here, what are you able to now adopt into your network? We have so many resources for all these features that we've mentioned, dedicated webinars, and you can also schedule one-on-one calls, right? So we want you to be able to, from this session, evaluate what you think you can do in your network, what you're already doing, and share with us as well what are some of the challenges you're facing. Okay. Thank you so much for this session. We really do hope you're able to leave your feedback and complete the survey. Tell us what we can do better to make this even a better session for you, and what information you wish you heard more of or maybe less of. But thank you so much. And from Sunil and I, thank you for attending the session.
Thank you.